How many minutes does it take to make a whole degree?
60.
Good. So 40 minutes would be how many degrees?
6.
Say again?
6.
Yeah, 40 divided by 60, right? Is that cool? Yes? No. Okay.
So for something like that, can we simplify it?
Yeah, totally. Yeah. But the funny thing is, I'm trying to make everybody's a nice whole number instead of being too freaky. So you should have gotten something like 6 minutes would be 6 out of 60 degrees, which is 1/10 of a degree, so 0.1. You guys see what I'm saying? Maybe. Okay. Everybody watch Jeff. There we go. All right. Is that all right? All right, everybody stop watching.
Watch Jeff at his finger.
Yay! Come on. All right, guys. Anything else? I mean,
I think when you're reference angles with the piece would hurt when.
yeah, too many of you guys, I said evaluate the following, and that means give me an answer. And too many guys just kind of did reference angle work and stopped. I mean, there were two parts of this problem. You got to figure out the reference angle and figure out the answer. So if I said, what's the tangent of 135 degrees? How do you figure out the reference angle?
180 minus 130.
Yeah, what's the reference angle defined to be?
It's based on the x.
Yeah, it's always based on the x-axis. So where is it? Yeah.
Just the question. So, reference angle is it just supposed to be similar to coterminal, right?
Say again?
Reference angles are supposed to be similar to coterminal, right?
Not at all. In no way at all.
Okay.
It's always how much did I go past or how much did I stop short of the x-axis? Because then I'm in the first quadrant, basically. Do you guys all agree with me that the reference angle will always be between 0 and 90 if I reference it to the x-axis? Because if I stop here, that's where 135 is. How far short did I stop of 180? 45 degrees. Does anyone know why 45 degrees kicks ass for tangent?
It's just 1.
Some kind of 1. So there are two parts to this problem after you figure out the reference angle is, now you know what quadrant you're in, you should know the sign, S-I-G-N, of the answer, right?
Mm-hmm.
You guys all with me? I love in trig, I gotta spell freaking words. You got a sign, and then you got a sign. It's like, so what should the sign of this be? Positive or negative?
Negative.
Why negative?
Because the x is negative.
Sine
y
is
positive.
positive, x, cosine is negative. Yeah. Okay. So so either I stop short of the x-axis, or I go past it. You know, so if I did, what do you got, Jeff? I don't know. Who knows what I got? 240 degrees. How far did I shoot past the x-axis? 60. So the reference angle is 60. You guys all with me? Yeah.
So for an angle like 135, why can't we use the y-axis as the point of reference?
Well, for that specific angle, it's the same either way, correct?
Yeah.
Now, the problem is, how did we talk about angles in the first quadrant? Isn't everything related to the x-axis?
Yeah.
If you want to memorize everything related to the y-axis, you can. Why would you want to? So we already have quadrant 1 memorized, and they are all related to the x-axis. Do you all agree? Because what's the x-axis? What's the positive x-axis? What angle is that? 0. That's where I start, correct? So every angle I talk about in the first quadrant is measured in relation to the x-axis. The whole purpose of a reference angle is to help me so I don't have to memorize every freaking quadrant. Do you want to memorize 210 degrees, 225 degrees? Do you want to memorize all of them? No, I'd rather just memorize 60 and 40 and 30, 45, 30, and then just look at the reference angle. Does that make any sense? The reference angle will always get me back to the first quadrant, and I have those memorized. Why does it get me back to the first quadrant? Because it's reference to the x-axis. And again, here, does everybody agree with me that these two triangles, the one that I go to at 135, this one, and this one, are they the same triangle?
Yeah.
Of course they are. And they both have the same base angle. So they both should have the same sine and the same cosine. The only difference could be the SIGN. Is it positive or negative? That's the power of love. No, that's the power of memorizing first quadrant and then reference angles. So I don't have to memorize anything outside of the first quadrant. That's all I need. Okay, maybe. So yeah, I did see a few people doing it with reference to the y-axis, but we don't have anything memorized in relation to the y-axis. Again, you can if you want to. You totally could. We could have totally made everything up based on the y. We totally could. We just didn't. Yeah, we had to pick a way. Okay. You guys all with me? I don't know if you guys understand what I just said, but we could have actually called this 0 degrees.
No.
Right? We could have. Do you guys agree that we could have?
Yeah.
Then everything would be in relation to the y-axis. Reference angles would be in relation to the y. It would all work the same.
Just the ugly.
We would just have different things memorized. Do you understand? Yeah, and I agree. It would be gross. No, screw that. Let's let that fade away. Okay. Again, it would work, right? Okay. All right. Anything else? Okay. So let's get into chapter 3.
I actually have one more question.
Oh.
From
What's up?
from part 2, number 3, with the co-terminal.
Yeah. Yeah. What's up? What's the question?
I didn't really understand what like the co-terminal.
So real quick, if I gave us a better angle, like 10 degrees, what does co-terminal mean? So here's 10 degrees roughly, you agree with me? So the question, co-terminal, is there another angle that if you follow it, you'll end up terminate in the same place? Co-terminal. Is there another angle that would end up in the same place?
370.
Yeah, if I go another 360 around, that would be 370, and it would end up in this. It would end up looking the same way, correct? How many co-terminal angles exist for any given angle? Infinite number, because I can add 38 times 360. I can subtract 23,000 times 360. Just so many rotations. Does that make sense? So the angle I gave you guys was something more like that, right?
Yeah, it was negative too.
Yeah, it was negative. Kick ass. So if you want to add 360 to this, that is 360 degrees, 0 minutes, minus 10 degrees, 41 minutes, not seconds. Right? And then you got to borrow. So this is exactly how we borrow in our number system. But here, real quick, watch this. This is going to seem really silly, but if I need to borrow, what do I actually do? I slice through that and put a 3. That means I just took how much?
10.
10. Because each one of these is 10, and if I added in this, that makes 10 plus 2 is 12. That's right. And I'm not saying that you guys don't understand. No, I'm not saying that. It's just we don't think about it, really. It's just sort of like the way we do things. So if I borrow 1 degree, how many minutes is that? 60. So now I can subtract this shit, right? You guys got it with me? Another way to do it, the way that I do this. What's up? Sorry.
Is it okay if you turn it into?
What's up? Sorry. You guys all right? Okay, sure.
I am not involved.
Sorry, it's okay to what?
Is it okay if you turn it?
No, because then you don't give me an exact answer. I want the exact answer, Dan. Yeah. You should be able to do this. Yep. So I kind of do this. I kind of do what would make a full degree. 19 would make a full degree, right? So that would make this 11, so 360 minus 11. Yeah. So there's other ways around it, but or you could just borrow. I think most of you guys do this, which is good. Of course, some of you guys just don't do that at all. You just sort of put stuff in. Not a good idea. Is that all right? Is that better for that one? So the idea is go forward or backward so many. I would only go one. Because I didn't say. You could have gone, you could add 3,600 if you really felt like it, because you could just do so many rotations. Yeah.
So,
Sorry.
would your answer be 360? Like find the two angles coterminous?
You got two answers you could get is add 360 to what I gave you and subtract 360 from what I gave you.
Okay.
That would be a forward rotation and a backward rotation. I'd end up in the same place. So if I want to look 10 degrees that way from where I am right now, I could just look like that. Or I could go 370 and now I'm still looking the same way, right? That's the idea. Or I could go back, right? Back 350 and I'd still be looking the same way.
It's a little bit dizzier now, but
Totally. Okay. Thankfully not that much. You never know. I was thinking to myself, what's going to happen to me? Oh, you're good. Don't worry. Okay. Everybody all right? Okay. Okay. All right, guys. All right, let's get into some new stuff. And what are corrections to the test do? Next test? Yeah, cool. Okay. So I think I know it's been a while, but do you guys remember why are there 360 degrees in a circle?
Because of the Babylonians.
Say again?
Babylonians?
Yeah, not because of them.
Well,
We
that's
stole it
how
from them. Yeah, they actually set it up and they were like, yeah, it sounds good. Is there any reason that has to be 360? It could have been 5,000. It could have been 3, right? You guys kind of, I need you to understand, the degrees, we completely made that shit up. Totally made it up, right?
Don't you mean we stole it?
Huh?
Don't you mean we stole it?
Well, I mean, we as humans made it up.
Okay.
Babylonians are a member of the human race, so yeah, they made it up. So we as the human race made it up. Is that better?
Yeah.
I agree with you. We want to get down to the details. We stole it, like we stole a lot of things, but let's not go into that.
But isn't it also because it's divisible by a lot of numbers as well?
Exactly. 360 is a really good choice because it's got a ton of factors,
Yeah.
right? I can break it up easily. Yes.
Well, then why wouldn't you just use 3,600 or 36?
Yeah, sure. We could have. This is the thing I need you to really be with me. You guys ready? Is everybody with me on? I need you to be with me. One thing I need you to understand is there's no reason it had to be 360. There's nothing special except it's nice, in which case you got a great point. Well, there's some numbers that are even nicer. Oh well. The real reason the Babylonians did it, and then we were lazy and we're like, that looks good, is because 360 is almost 365, which is the number of days in a year. And of course, I think we talked about ancient civilizations, agriculture's huge, how long the year is huge. You guys kind of with me? Okay, I like it. Okay. The real point of this then is that shit's made up. Let's use something better. There's got to be something we can use that's better, that's actually physical, has a physical meaning to measure angles. Let me ask you this real quick. If I write sine of 90 degrees, okay, what is that? 1. If I write sine of a right angle, what is that? No trick. Sine of a right angle. You just told me. 1. You guys all with me? The reason that the fact that degrees are made up doesn't matter for everything we've done so far is because it doesn't matter what the shit I put in here. I just need an accurate description. If I wrote sine of that, not L, but you understand what I'm saying here? Right angle, that's 1. I don't need, we're not doing the sine of, we're not doing something to 90. Do you all agree with me? I'm not taking 90 and dividing it by 90 or something stupid. You guys all with me? I'm just memorizing, oh yeah, a right angle has a 1 is the sine. We just memorize that. So it does not matter what the number is on the inside of the trig function. It just has to reference a certain kind of angle. Are you guys all with me? You with me? Okay. right? There must be. So are angles always stuck inside of trig functions? No. Sometimes they're just out in the wild, right? So then I want a measurement of angles that is physical, not made up. Does that make sense by itself? I need a way to measure angles that isn't just made up, that's actually physical, that's related to the circle itself. Okay, I'm kind of excited because this is so freaking cool if you've never seen this. Hey, has anybody ever heard of radians? This has come up before, so everybody has. Even before this class, though. Anybody ever seen it before, know what it really is? What is it?
It's like the physical measurement of a circle, but instead of using like the degree, it's in pi.
True, but more fundamentally than that. Yeah?
Isn't it more based on the radius?
Yes, so watch this. This is so cool. If I have this circle, and there's a radius, R. If I take the radius, I'm going to pick the radius up. I'm going to pick it up, and I'm going to put it there. There it is, right? Y'all with me? I'm going to take that, I'm going to bend it. Right? I'm going to bend that radius so that it perfectly matches the curvature of the circle. So I'm going to bend it. This is one radius. I'm going to bend it, and now I'm going to take that and I'm going to put it back on the circle. Come here, Baloo. I'm going to take this and I'm going to put it back on the circle. There. Well, you're fine, Jeff. How long is this blue section here? R. Exactly. That's what it is, right? It's the radius. Whatever the radius is, if the radius is 11 feet, that's 11 feet. You guys all with me? Didn't I just go through an angle, though? Yeah. Anytime I walk around a circle, didn't I go through an angle? You guys all with me so far? This is where the word comes from. That is, this angle is 1 radian. That literally means it is 1 radius worth of length. You stop for a minute. Yes?
How can the length of the curvature on the circle be equal to r? Shouldn't it be like pi r or something?
Nope.
How come?
Because that's how I made it. I took the radius, I bent it, and I put it back on. There's no question. If I do that, there is zero question that this is exactly r long. We're getting to what you're thinking about. You're mixing a couple things. How's everybody else doing? Yes?
In the book, I saw that it's like 2.
We're not there yet. We're getting there. I love you guys so much. That angle I have drawn so far as a measure of 1 radian. If I lay 2 radii down, what would the angle be?
2 radians.
2 radians, yeah. So if I plop another radius worth down, this would now be 2 radians. Do you guys see? So then the question becomes, is everybody else all right? I think somebody else had a hand up there. Then the question becomes, how many radians does it take to get all the way around the freaking circle? So before I do that, I want you to notice something. The circle I've drawn is a certain size, right? Of course it is. Yes, Jeff, it is. Well, dang it, I just have 2 colors. Too bad for everybody. If I were to make a smaller circle, I need you all to realize, if I take its radius, right? Y'all with me? And I bend it, and I take that and I put it back on the circle, it would perfectly match up. Why would I expect that? Because if the circle shrinks, so does the radius, directly proportionally. So the choice of using how far a radius would take me, or a part of a radius, for the angle measure is a physical measurement. And it doesn't matter how big or small the circle gets, because it will scale up and scale down automatically. I don't know if you guys are with me. Yes?
So it's a set amount of radians in a circle.
Totally. That's the next step. We're going to figure out how many radians are in a circle then. Which really, what does that really mean? How many times can I lay a radius down that will get me all the way back? Do you guys think it's a whole number? Hell no, right? It's a pretty good guess with circles that things aren't going to be whole numbers very often. Are you guys with me? Because, of course, somebody already brought up the magic letter, the Greek letter, pi, right? Really quick on the side. Where the hell did pi come from? From an oven? No, shut up. Sorry. Yeah, I know. I'm a
I
math.
almost said a bakery, but
Smith Bakery's even better. Huh? Dad jokes and math dad jokes is good.
Something that you eat.
So, anybody actually know where we came up with the idea of pi? No, okay. If I take any circle, I don't care how small or how big, right? Take the earth, pretend like it's a sphere, cut it in half. I've made this gigantic circle. Everybody with me? I don't care how big or small. If I take the diameter and the circumference, if I divide them, it always comes out to be the same number. So the Egyptians estimated it to be 22 divided by 7. Who's got a calculator out? What's 22 divided by 7? 3.1428. 28. And what's pi? 3.14159. About.
yes, 9.14.
Yeah, so they got pretty damn close, yeah? This tripped people out. This freaked us out as a human species. When we looked at a circle and we went, wait a minute, I don't care how big the damn thing is, it's always the same number when I divide these things. So we gave it a special letter, because that's freaky. That must have come from the gods, is what we thought way back in the day, right? So we decided to give this number the letter pi. We decided to use a Greek letter. We chose pi. Because we all think of pi when we're cutting this thing up. Big old slab of pie, right? That's not the real reason, but sure.
It works.
Y'all, has anybody ever heard that before? We gave it a symbol. It is a number that exists. It's what you get, however big a circle. If you took something and you measured it with a piece of string, and you measured the diameter, and then you lay the string out, and you measured the circumference, and measured the length of the string, yes? Measure the length of the strings, divide those two, you're going to get close to 3.14, blah, 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 blah. You guys semi with me? Okay. Since pi is going to rule our life very soon, I want you to all know where the hell it came from. Y'all with me? We didn't just go, yeah, pi, 3.14 something. Yeah, that sounds good. No, we gave it a letter because it freaked us out. We did that with other shit too. I don't know how many of you guys know E. Yeah, some of you guys know E, and that came about for all kinds of reasons. We're not going to get into that. E's not part of it. Okay. So that little side note was just to talk about where the hell pi comes from, because pi is about to come into things. So, can anybody tell me then what the circumference of this circle is, based on what we just talked about?
2 pi.
What's the diameter? How does it relate to the radius?
2
So there's a formula for circumference, right? So that would be the circumference of the circle, correct? Because I don't know what r is. Are y'all with me? So we actually know the answer to how many radians are there around a circle. What's a radian again? It's the measure of a radius, correct? So how many radii does it take to go all the way around the circle? How many radii? 2 pi. 2 pi radii. Sorry. It rhymed, I liked it. Okay. You guys semi with me? Again, let me do this again. Is everybody cool with this equation? Yeah. Okay. Either remember it, or it comes actually from that definition and the fact that the diameter is twice the radius. Is everybody actually cool with that equation? 1 radius is the distance a 1 radian is the distance a radius goes. So if I wanted to go 2 radii, it would be over to here. Is that cool? Okay. So now the question is, how many radii does it take to get all the way around the circle? We actually know it takes 2 pi radii. Let me stop for a minute. So if the radius was 6, how far is this? 12. Is everybody cool with that? Because it would be 2 times 6. That's crazy. So how many, so if it was 3 times 6, how many radii did I go? 3, yes? This is 2 pi times radius. So how many radii did I go? 2 pi. If you understand this, 3 times 6 would mean I went 3 radii around. It's not quite there. Yes? Is that cool? 1 radius would be one radian would be 1 radius. 2 radians would be 2 radii. So how many radii did it take to get all the way around the circle? 2 pi of them. That's all the way around the circle is 2 pi. Let me stop for a minute.
So would it be like 2 times, so like for example with the radius, you said 6, right? So like would it be like 2 pi times 6?
Yes, that would be the circumference, yes.
Oh.
Yes. So, in any circle, how many radians does it take to get all the way around? It takes 2 pi radians to get around. If I had a circle of radius 1, and of course, what kind of circle is that? That's the unit circle. It's got a radius of 1. What will the circumference be? Yeah. Radius is 1. Circumference would be 2 pi r. Circumference would be 2 pi. I like it, right? If I make the circle bigger, then it still is going to take 2 pi radians to get around. It's just the radius is bigger now. So that's why I can still get around in 2 pi of them. No matter how big or small the circle is, it will always take 2 pi of the radians to get all the way around, of the radii, to get all the way around. So a circle has, by definition, 360 degrees in it. Better than that, wish we had never came up with that shit. Better than that, it has 2 pi radians in the whole circle. That's how many radians it has. So that's how many, whatever the radius is, how many radii would I have to walk around to get all the way to the end of the circle? I would have to walk 2 pi of them. What is 2 pi roughly? 6.28. Is that cool? 3.14 doubled is 6.28. You guys with me?
Yeah.
So if I laid 6.28 radii around the circle, I would get all the way around the circle. Like we predicted, it's not a nice whole number of radius. A little more than 6. So whatever the circle is, if I take the radius and I put it on the circumference, it'll take a little over 6 of them to get all the way around. Okay, let me stop for a minute. Yes?
So if we talk about it in terms of radians, would it take 8 radians to get around the circle?
8? No. Why 8?
Well, you said like, when I looked at your example, you said like 1 radian would get us like roughly about 1/8 of the circle.
I never said 1/8.
Like
Yeah.
if you do 2 radians, wouldn't it be straight vertical?
No. Nope.
Would it be?
So, I'm not sure where I'm losing everybody. Help me out.
I think you losing us with the pi situation, like, you know, like how is, like first off, pi is not a whole number type of thing, so then.
Sure.
So then like, how is it,
Alright,
like
guys.
at
I'm on a
1/8 is
circle.
pi?
I'm on a circle, right? And let's say the radius is 11. And I walk 22 let's say 11 meters, and I walk 22 meters around the circle, how many radians did I go? 2 radians. Because that's 2 times 11. That is 2 times the radius length, correct? Y'all with me? Does that make sense so far? If I say 2 times radius, that 2 is the number of radii. And what are radians again? A certain number of radii. So this would mean that I've gone, the angle would be 2 radians. Why? Because it took 2 radii to get there. Is everybody cool with that?
Because you multiply it by 2, right?
Exactly. If I know how long a radius is and I go 2 of them, I just multiply to see how far I went. Is everybody with me? So it really is that right now. That's what it is, beautiful. So if I know a radius is whatever, I can use that as a benchmark. Okay, you guys with me? Sort of like we could use miles or kilometers, correct? And if I use one or the other thing, I'm going to have different numbers to measure the same distance. You with me? So if I use the radius as a benchmark, I go 1 of them, I go 2 of them. We stop for a minute. Okay. So whatever number is in front of the R is the number of these that have gone. Does that make sense so far? If I go another one, that's going to be 3R now, right? This will be 3R. Wow. Somebody with me? That'll be 33 meters that have gone. If you want a nice concrete number, is everybody with me? Does that make sense so far? Nothing more to it than that. I'm just using this distance as like a tick mark on what I'm measuring. 1 of these would be 11, 2 of these would be 22, so forth. You guys all with me? So if I wrote this, what would that mean I've done? I've gone 6 radians. I've gone 6 radii worth of length, which is 6 radians. So whatever number is right here, that's the number of radians, because what's a radian is how big a radius is. So if I've gone 6 of these, I've gone 6 radians. So ready with me so far? So if I'm here, I've gone 2 radians. So radian really just means the length of a radius. So I'm using that as a tick mark. You guys kind of with me? Okay. So remind me, and the circumference is how many radii? What's the formula? 2 pi. So how many, to get all the way around the circle, how many radii have I gone? 2 pi of them. So remind me, what did it mean right here? This meant I've gone 2 radii, that's 2 radians, correct? Whatever number's in front of the R is the number of radians we've gone. It's how many radii have gone. Isn't this 2 pi of them? So there is 2 pi radians in a circle. Okay. Maybe. Yes?
Is it because circumference divided by the diameter is equal to pi? So then, like, if you were to get circumference on one side, and then now diameter is 2 radii.
2 radians, which is what I had up here earlier.
Right.
Yep.
So then that's why it's 2 times pi times radians, because the first equation, right?
Yeah, totally.
Okay.
Yeah, that was the whole purpose of all that. And then I had both of those formulas up here. Yeah, okay. Yes?
Why can't you just use diameter?
We could.
Is it a 2 pi? Is it a 2 pi?
There's if you look up, there's a Greek symbol, tau. There are math people who wish instead of pi we use tau, and all tau is 2 pi. So we could have based everything, we could have made 2 pi like its own symbol, tau, right? But we didn't. We could have. Again, there's so many things we could have done, but it wasn't the way it was done. And if we try to do it now, everything else is in terms of this other thing, we're going to be like, what the shit? It's sort of like trying to use meters in America, basically. You know, instead of every other country on the face of the earth. I'm not bitter about that. Okay. Another way to look at this. Let me ask you this. Let me ask you this. Here. Let me see if we're doing all right with some concrete stuff. Let's do some concrete stuff. If I have a circle of radius 3, right? Circle of radius 3. 3 feet, and I walk 9 feet. How many radiuses did I go?
3.
So are we cool with that? So we just went 3 radians, correct? So physically, I walked 9 feet. That's equivalent to I went through an angle of 3 radians. Because each radius is 3 feet. Are you guys with me? Okay. So what if I go, what if this is R, and I go, what do you got, Jeff? And I go 3R. How many radians did I just go through?
3.
It's the same question, right? I just made R instead of 3. Is everybody with me? Okay, so how far do I go? What's the formula for how far I go to get all the way around? What's the formula?
2 pi r.
That literally means 2 pi radiuses, radii, right? So remember, when it was 3r, and I want to know how many, didn't we just divide by r to see how many radians we went? Because each r is a radian. Are you guys with me? You guys with me? Up here, why did you divide by 3? To figure out it was 3 radians. Why did you do that? Because each radius is 3 feet. So don't I just take the distance I've gone, divide by the radius, and that'll give me the number of radii? Is that all right? All right. All the way around the circle is 2 pi r. If I divide that by r, it'll tell me the radians. There are 2 pi radians around the circle. Okay. Yes.
So R is just a placeholder for like that distance that you're talking about? So
R literally is, yeah, so if I wanted the circumference of this thing, I would just do 2 pi times 3, yes?
Right.
Yeah.
And
yeah.
that's because you're saying like they figured out that it's like everything's directly proportional no matter how big or small that circle is, it's all gonna be 2 pi r, right? Like it doesn't matter what r is, 2 pi is gonna get you all the way.
Exactly.
Okay.
That's exactly it. If the radius gets bigger, then the steps I take gets bigger. I still just takes 2 pi to get around. So you could say, okay, it takes me 2 pi radii to get around this circle. What about this circle? Well, now the radii are bigger. Now every step I take is bigger, and I still take 2 pi to get around the damn circle. Yes?
So like for a unit circle, 180 would be 2 pi.
Nope. No, careful. No. Okay.
Or no.
Are we ready for this? This is my next step. That's my next step. It's almost like it planted you there to ask that question. All right. Is everybody okay with this now? Okay. The funny thing is the formula gives it away. If a radian is the number of these, then how many radians in a full circle? This many. That gives it away. Yeah.
So what I'm not understanding is how you, like you said, 2 pi r divided by r equals 2 pi radians?
Yes.
What do you mean by that?
So again,
Radians.
again. Let's say that this radius is 7, and I go. Let's do this, and I go 3.5 meters. Have I gone a full radian?
No.
How much of a radian have I gone through? How did you get that? The distance I went divided by how big each radius. Of course you did that, because I'm trying to figure out how many radii is that. So I'm going to divide by how big a freaking radius is to see how many. It's not a full radius, correct? It's not a full radius. So I know the answer is going to come out some decimal, and of course it's 1/2. So that is 0.5 radians. That would be an angle of half of a radian, because it only made it through half of a radius as it turned. Is that all right? So, no matter how far I go around the circle, I can divide by the radius and see how many radians I went around it. That's the idea. So if all the way around the circle is 2 pi r, divide that by how big the radius is, I get 2 pi of them. I get 2 pi radians in a circle. And that is a physical measurement, not some made-up degrees bullshit. Okay, maybe. You guys all love this very much, I can tell. Now, based on this question from back there, this is where the next place to go. So what do we know so far? We knew before today how many degrees did it take to get all the way around the circle. circle, by definition, we just said, yeah, 360 sounds good. So if I go around a circle, that's 360 degrees. We now know that to get around the circle, how many radians does it take? 2 pi. So 2 pi radians is the same thing as 360 degrees. They're the same thing. That leads to being able to convert between these. How many inches in a foot? 12. Can I convert between inches and feet?
Yeah.
Since I know that, correct? How many radians in 360 degrees? 2 pi.
2 pi.
So could I convert between those?
Yeah.
Yeah, I like the hesitation, you know, like, it's weird shit up there, man, it's not 12. It's freaking pi. So, let's improve this a little bit. Can I divide both these by 2?
Yeah.
In fact, let me ask you, this is 2 pi, what is this?
Just pi.
That's pi. And what angle is that in degrees? 180 degrees. And if I just divide these by 2, don't I get 180 degrees equals pi? It's got to be consistent, right? If you ever notice an inconsistency in math, you're looking at it wrong, come talk to me. Or you deserve a Nobel Prize in math. That's all I mean. I need you to understand, we got to that answer in 2 different ways. Halfway must be pi, and that's 180, and sure enough, we just take this stupid thing and divide by 2, we get the same thing we just said. 180 degrees is the same thing as pi radians, yeah.
So, okay. So 180 degrees equals pi, but then when you put pi into a calculator, you get 3.14.
Alright. Because I need you to understand, yes, this is still 3.14, blah, blah, blah. That is still exactly what that is. Exactly what that is. So, if I knew what the radius was, and I go pi radians, I get there, correct?
Right.
How far do I actually go? I want pi radians. How big is each radius? 10. So I want pi radiuses, radians, radii, and each one is 10 big. I want 10 pi. Okay, right? So this still is 3.1. It still is that number. Anytime you see pi, that's what it is. But it also is, it represents the same thing as 180 degrees. So in a circle, if I go pi radians, that is the same thing as going 180 degrees. Just like 1 foot is the same thing as 12 inches. Does that say 1 equals 12? Does 1 equal 12? No, 1 foot is 12 inches. Not a damn thing wrong with that statement, right? But if you say 1 equals 12, I'm going to look at you funny. You with? Does that make sense? Because that sounds like it's kind of related to what you're having trouble with the statement.
Yeah.
This is 1 unit of measurement. This is a different unit of measurement. But they both end up measuring the exact same angle. Does that make sense? Okay. Yes?
So is the reason why we use 2 pi r because we're looking at right triangles?
No, not at all.
Okay.
It's just because this is true by definition.
Yeah.
Therefore, this is true by definition.
What? Okay.
So that's just how we figure out how far it is around a circle. That's it. I'm not even bringing right triangles into it right now, right? This is all just circles. Yeah.
So you said you went around 10 pi radians because of the 180 degrees?
Yes. So this would be, so whatever 10 times pi is, it would be 31.4159, blah, 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 blah. Right? You guys with me?
What's the units for that, radians?
Whatever the unit's here. I didn't give it, so there. Feet. I love you guys. We're getting there. We're not quite to conversions yet. So let me ask you this. Okay. Does anyone know how tall you are? Pretty much exactly. Yeah, how tall are you?
5'7", which is like 67.
67 inches. Okay. What's your name again? I'm sorry.
Doug.
Doug. Okay. Sorry, Doug. Can't I measure this wall in Doug's?
Yes.
Couldn't I measure this wall in Doug's?
You could, and I would like to see you try it.
The number of Dougs. And Doug, don't do this, but I could ask you to lay on the ground, and then I'll mark it, and then you come over and you lay down. You guys with me? I'd mark where his head goes, and then you come over and put his feet where his head was, and keep going, and we can see how many Dougs this wall is. Silly, yes? You guys with me though? Didn't we just make up frickin' inches? Did aliens come and say, if you don't use this, we're going to shoot you? No.
Right, well, you
We're
know,
going to shoot you with their lasers, right? No, we just made that shit up. In fact, we're the only country that still uses the damn things. You guys know that? The rest of the world uses centimeters and stuff. You guys kind of with me?
Oh,
Did it have to be that? We made the shit up. So, we could use degrees to measure how far it takes to get around a circle. And we all agree. I don't know if we all agree, but I need you to understand that's completely, could have been anything. Could have been anything. There's nothing special about 360. Do you guys all understand that? Everybody understand that? Nothing special about 360. If I just drew a circle and I didn't know shit, I'm not going to go, oh, 360. No. It's the number we picked. This is trying to say, oh, no. Let's not use degrees, made up shit. Let's use radii. Sort of like Doug. Use Doug to measure so the building could be 20 Dougs tall or whatever. You guys with me? You guys understand? 20 Dougs would be 20 times 67 would be that many inches. You guys with me? And then I can make it feet. You guys semi with me? I need you to be semi with me. I know this is weird. How many times do you have a teacher talking about, let's measure this in terms of student, Doug? And of course, if I pick somebody else, it'd be a different number, correct? So what makes sense for every circle that exists? Don't they all have a freaking radius? They come with a Doug. They come with a tool I can use to measure itself. And the beautiful thing is, if it takes so many to go through this angle, every circle will take the exact same number of radii to go through that same angle. Does that make sense? Because if I make the circle smaller, the radius gets smaller. That many radii still goes the same exact distance. Is that right? Okay. Does that? All right. Okay. So, now the question is, how do you convert between these things? So let me ask you this. If I have a measurement of an angle, and in general, just to let you guys know, this is why I put little degree symbols when I think about it. You have to put the degree symbol if you mean degrees, because if you don't see a symbol, it's radians. So if I ask you what is the sine of 7, that's not degrees, because they didn't put a degree. Do you guys see that? If it doesn't say something, it's understood to be radians. But I don't blame you if you write rads. That's fine. That means the same thing. Times, okay, we're getting there. All right. So help me out. Pi radians is how many degrees again? 180 degrees. So watch this. This is kind of cool. I need you to understand. Going from radians to degrees is really nice if pi is in there. What would pi over 6 radians be?
30.
Yeah, what was pi again? How many degrees is pi radians?
180.
Can't I just directly replace it? Sort of like if I saw 3 feet, can't I just replace feet with 12 inches? Isn't that 36 inches now? Do you guys see what I'm saying? So if I see pi something radians, I can replace pi with 180 degrees because that's what the shit it is, yes? So how many degrees is pi over 6?
30.
30 degrees. Don't say anything. Don't say anything. What's that? Don't say anything. Just figure out what that is. Don't say anything. All right. What is that?
45.
45 degrees. How'd you get that?
180 divided by
180 divided by 4, yeah. Let me stop for a minute. Yes?
Never mind, I was gonna ask, like, what, why you chose 180, or like, if we were telling you to divide by.
No, I need you. I didn't choose it. So if I convert 3 feet to inches, do I choose 12? I didn't choose it, right? Why is 12 involved? Why is the number 12 involved in this?
convergences.
Because 12 inches make a foot, right? So of course 12 is going to be involved. So when I'm converting between radians and degrees, pi radians is 180, just like 1 foot is 12 inches.
Okay.
So I didn't make a choice, it's just what it is, right? Pi radians is 180 degrees. They represent the exact same amount of rotation. So that means just like 1 foot represents the exact same amount of length as 12 inches. You guys with me? Exactly the same idea. Okay. So when I see a pi in the radians, that's relatively easy to convert. If I want to go from degrees to radians, that kind of sucks a little bit. But let me show you something that's really nice. So if I have, what do you got, Jeff? Yeah, if I have 135 degrees and want to convert that to radians,
3, 4.
we'll get there, hold on. I could do this on 35 degrees. I don't know if you guys have ever seen this before. This is a great way to do conversions. If you ever taken any chemistry, this should look familiar. No Avogadro's number though, don't freak out. Oh my God. Sorry. What unit do I want to get rid of?
Degrees.
I want to be all in radians. I don't want any degrees, correct? So I'm going to put degrees down here. And I want to be in radians, correct?
Yeah.
How many of which is in what?
1 radian.
No, careful. No. 1 radian is freaky. 1 radian is a very interesting number.
Pi.
Pi radians is how many degrees?
180.
180. Can you reduce this? Some of you guys are like, yes, I can. Well, then do it. What goes into both?
4.
Huh? Yeah, 45. I love it. 45 goes into both, yes. I just didn't expect that. So watch. Okay, a couple things. I know a lot's coming out. It's almost time to go. Do you guys know the rule about how to tell if something's divisible by 9, for example? If all the digits
Add up to 9.
or a multiple of 9.
Yes.
What's 1 plus 3 plus 5? 9. What's 1 plus 8 plus 0? All right, so what's 135 divided by 9? 4. 135 divided by 9? What? 135 divided by 9. 15. What's 180 divided by 9?
20.
20. Now I got much easier numbers, yes?
Yes.
That's 5 goes into that, 5 goes into that, so I get 3 pi over 4
I was
radians.
thinking 135 divided by 4. Never mind.
Gotcha. Last thing I'll say. Do you remember how right here we got pi over 4 is 45 degrees? Right? Where's pi? Pi radians, where is it? It's in the same place as what? 180 degrees. Where's 180 degrees? Here. That's pi. Here's 135. Isn't that 1/4 of a pi? Isn't that 45 degrees short? Isn't that pi over 4 short? So what's a whole pi minus 1/4 of a pi?
3/4 of a pi.
3/4 of a pi. So what we're about to get into, the nifty thing is, a lot of chapter 3 we've done already. Because if you know what the sine of 45 degrees is, that means you know what the sine of pi over 4 is. Because they're the same damn thing. You see what I'm saying? So what we got to do over the next couple of classes is get really used to radians. Right now, don't freak out if you're not, because how long in your life have you talked about it right now? For a lot of you guys, less than an hour. Yeah. So don't. All right, some of you guys you've talked about it before. You should know it then, damn it.
Yeah.
So is pi, like, if we have a number of pi, it's always the units of radians?